In this video lesson here, I am going to bring up an example of how we can calculate rate of change with revenue functions. And so let's begin again. Let's begin by reading the wording description of our example here. So the total revenue function for a blender. So think about, you can pretend that, for any viewers watching this video, you can pretend that you are running a company that's selling blender. Okay, so the total revenue for a kind of blender is given by this function right here, R of X. So revenue in business application, admittedly, the capital letter R is famously used to represent revenue. So R of X here is indicating the revenue function as a function in terms of X. So R of X equals 34X minus 0.03X squared. So that's some good information to highlight. Okay, and so now with a quick explanation of what the X variable means, where X is the number of units sold. Okay, so you have your own store, you run your own business that's selling these blenders right here. And so when you're selling X blenders, then this is how we can determine your revenue right there. Okay, and of course for a business student, who are on track, even though studying calculus, but who are on track to study calculus to apply to business, then you are expected to know what revenue is, or already at least some basic concept of what revenue is. So now getting into question A, what is the average rate of change? So here you go, here we are, that term again. What is the average rate of change in revenue, R of X, or rate of change in R of X, as X increases, or another way of saying X changes from 20 to 30 units. Okay, so a function is not only dependent on a function's output value. It's not only dependent on the input variable being the time variable, as many of you have seen my many other video lectures, that mostly I design examples. I selected examples where a function's output value are dependent on the time variable. But see, obviously right here in this example of ours, it's particularly important for people who are going into business professions. Then your revenue can entirely be a quantity that's dependent on the units, the number of units that you are selling away, that your store is selling away, or your own business is making and selling away. Okay, and so in that way, allow me to quickly sketch down the function itself again before we get any further. So R here is our function. R of X is defined as a function 34X minus 0.03X squared. And then, yes, X is the number of units. And here in this particular problem, the units here, I'm talking about how many blenders being sold. Why is a problem like this so important for anyone who is about to run a business and open your own business? It helps you understand, at least it helps you understand and have some good idea about a planning for your business. I will give more, hopefully a little bit more in-depth explanation as we finish with this example. Okay, so everything starts with that revenue function here. So X is the number of units sold. So it's not only just a math problem out there. So now, as the question was stating, find the average rate of change. Find the average rate of change. It's right here being highlighted, that piece of highlighted information. And so in that way, clearly speaking, as we have already seen throughout the discussion lecture on rate of change and instantaneous rate of change, then average rate of change again is where we find a kind of rate of change that happened in a given finite interval where there was a beginning and there's an ending of our interval. So now here the question was stating that find the average rate of change as x as the number of units being changes or increases from 20 to 30 units. So that means as simple as it can, we are going to evaluate our final revenue, the kind of revenue that happens at when you are selling 30 units away. Okay, and so of course the interval that you are given is the interval from 20 that changes from 20 to 30. And what I was saying a little bit earlier about planning, see, it's about the kind of when you decide to increase your selling, okay, increase the amount of selling, and that's why it's related to planning of your own business right there. When you change the quantity from a certain quantity to another certain quantity, there are a couple of things to watch for. It's especially the rate of change in revenue, especially because a lot of time, you know, when we're selling things, we always want to sell more units, but it's not always a good thing because it could give us a negative revenue sometimes. Okay, so that's something to watch out for. And so for the best, doing these calculations helps you have a good idea about your own planning. So now back to what I was about to do right here. Finding an average rate of change is just simply, well, average rate of change. And here, of course, change in revenue. That is just according to what we have already learned. Revenue when we're selling particularly 30 units. Okay, and this is what in strict math terms, final output value of our function R here, and we're subtracting R at 20. This particular meaning the revenue when we're selling at 20 units. Okay, but in a strict math term, this is initial function output value, and of course that difference here is divided by 30 minus 20. The final point of our interval, subtract the initial point of our interval, and that is famously the formula calculating the average rate of change. Okay, so in that way, now I'm ready for doing some calculation, and so all right, and I just now realized I had a little typo here earlier as I was copying down the actual questions from the computer screen, but this here is supposedly 34. Okay, so in our calculation, the calculation I just received now came out being, so the revenue when we're selling 30 units, that would give us $993, and here it's the revenue here. Just pretend that we are just a small company, a small business, a small store, and when you're selling 30 of these blenders, and it makes sense, the blenders should be just not that expensive. Okay, so 993 to be your revenue, so for selling 30 units or 30 blenders, and then you're gonna subtract now the revenue for the total revenue for selling 20 blenders is going to be 668, and just let me make sure I copy it down correctly. And now we're dividing by, so this is a change in between final revenue and initial revenue, and now we're dividing by 10. Okay, because 30 minus 20 is 10. All right, so now here we are at the final answer. Here we're looking at a positive 32.5, and this is in dollars, of course. So this is the rate of change, the average rate of change. Okay, the average rate of change for revenue right here. But now I am going to step to the other board and give some quick interpretation of that answer. So note how we've had a positive answer in our, a positive sign in our answer. So that means, okay, the revenue having a positive rate of change there as indicated in the answer here. Now, in the practical meaning, the revenue increased, okay, or grew again. The revenue increased, okay, at rate. And so how do I know it was increased? It was increasing because we had a positive rate, but the revenue, as we change from selling 20 units to 30 units at $32.5 per, but now this time per blender, because so it's unlike many other examples that I have right here where the function is in terms of time. Then here the rate of change can also be measured in terms of, you know, per blender. So think about on average, if you're selling any in that interval from 20 to 30 right there, then you are adding into your revenue. The idea is you're increasing. So you're adding into your revenue about, on average, about $32.5 per blender. And that's the meaning of this average rate of change. But of course, so as you have seen throughout the general discussion lecture, then average rate of change can never be exact, can never be precise. And that is the reason why. Now let's advance over to our next question in the example. All right, so here we are. Let's look at part B of the example. So now I can see that in this part, same function given, supposedly, and x has the same meaning. X is the number of the units being sold by that store, by our store, by my store, whatsoever. Okay, but now the question is asking for, what is the instantaneous rate of change of revenue if 25 units are sold, 25 blenders are sold specifically? So again, as a reminder, an instantaneous rate of change is the kind of rate of change where it only happens at one instant. So I'm using the term instance, make it feel like it's time, but really here we're talking about right at that instance where you decide, right at that instant where your store is selling at exactly 25 blenders, okay? Not 26, not 25.5. Well, for blenders, we can't really have a 25.5. But now the idea is when you are selling exactly 25 units, okay? What is the rate of change at that particular quantity? Okay, at that particular quantity that you're selling. Okay, so we overuse the term instantaneous, making a lot of viewers, tie their minds down to, instantaneous means in terms of time. But here, the instance I'm talking about is the instance where x equals 25. Okay, our main variable equals 25. Okay, and so again, we need the derivative. Because in the way how it is, being an instance, we are only given one value. Instead of having an interval, we're only given one value. The value is x equals 25. So we want to know, is the revenue increasing or decreasing when we are selling specifically 25 units? Okay? And so that means here we are only given at x equals 25, according to what's being described in the question of the example. So now to get that instantaneous rate of change, first tool we need r prime, the derivative of our r function. And that's the reason why we can only do this, we can only handle this kind of problem, we can only handle this kind of application when we are learning some certain amount of calculus work, especially derivative work. Okay, so r prime of x in this case equals, and I hope anyone viewing this video at this point is fluent in terms of taking your derivative with basic derivative rules right there. So it's 34 minus 0.06x, okay, because the power rules allows me to multiply that 2 to the front coefficient, making it 0.06, and the power reduced by 1, and that's how we're ending at 34 minus 0.06x. All right, so this is the general derivative. It's indicating the general instantaneous rate of change of this function at any time. But specifically at that instance where where x equals 25, we're looking at rate of change of revenue at 25, R prime at 25. And yes, maybe this time let me write it in red ink to highlight the meaning right here. The instantaneous, okay, the instantaneous rate of change. All right, all that there equals R prime at 25, because the derivative here is just only some general regulation of how we can obtain the instantaneous rate of change at any specific given value. But now, so R prime at 25 means we are going to substitute x equals 25 into our derivative. So 34 minus 0.06 times 25. And it's a multiplication right there. All right, so I am going to need another moment to do a calculation. And I should be back shortly. All right, so now I'm back with some calculation. Thus, R prime at 25 will come out, according to my calculation, 32.5 again. Okay, so 32.5. And so as far as getting an answer, we got an answer. And as the units, this means 32.5 is $32.50. Okay, that's money, our US currency right there, per blender. That's what it is as with units. But now again, I'm still going to step to the other board to give some understandable interpretation of this. All right. So now I'm saying at exactly x equals 25. This means 25 blenders are sold. Okay. The revenue. We had a positive rate of change value. So that means the revenue here is increasing. Okay, so we're increasing our revenue when we're selling at that particular number of number of units right there. So we have an increment in our revenue, and it's increasing at, how fast is that? At $32.50 per blender. And the revenue is increasing means, expectedly right at that instance, then our company our store is gaining revenue by 32.5 blender. But do not assume that this is going to be the same for the rest of it, because as I said, this is instantaneous. It's only happening when x equals 25. Feel free to try again the same example with the same function, but after you have your R prime, try x equals 26, just one more units compared to 25 like that, and trust me, the value will come out different. And so that's why I just want to reinforce that idea that the rates, the kind of rates we found here, very exact, but only happens at that instance, only true, only applicable right at that instance. The next one, it may give you the same value of the rates, but it's in the end it's still a different rate. Okay, and that's the whole idea of instantaneous rate of change. And so in the beginning of the video, I was saying about something about this example could be good to trigger up for people who are running your own business. Think about you run your own store. This example can help you in terms of planning, make a good planning for your business. Think about it, because I I expect anyone viewing this video to already have seen either some of my past videos where I show basic skills of how to derive these revenue functions. But assuming at this point when you're viewing this video, you already understand how a lot of time in your business applications, revenue is heavily dependent on the quantity being sold out there. Then see, planning I'm talking about here is the kind of planning that a lot of time we want to choose the best number of, or we want to aim for the best number of units being sold so that we can maximize or we can bring the best rates to gain our revenue. Okay, it's the best rate to gain our revenue. So right here, this example is only staying on the basic of how we, on the very basic side of how we apply the understanding of derivative. But later on, you will see an example very similar to this being, resurfaced again, but where we're going to apply, like what I said earlier, we want to maximize. See, maybe for someone doing a business, growing your revenue or increasing your revenue at 32.5 per blender is maybe not satisfying enough. You want even more growing, a faster rate. How can we do that? It's all about back to, there are strategies, there are techniques, and the calculus you're learning will be able to help you with those. But how we can, what value for X right here, what number of units being sold that can give you the best rate of change, the best instantaneous rate of change in your revenue. Okay, and that's the idea about how example of problem like this can help you in terms of planning for your actual business that any of you viewing this video, but in the meantime you are running your own business.